Mr. Sharma and Mr. Sharma, Mrs. and Mr. Ahuja, along with four other persons, are to be seated at a round table for dinner. Right? If Mrs. and Mr. Sharma are to be seated next to each other, and Mrs. and Mr. Ahuja are not to be seated next to each other, then the total number of seating arrangements are lovely. For 8 people around a circle. 8 people around a circle is 7 factorial. That we know. But this is not that. We are told that there are 2 couples. One couple have to be seated next to each other. Another couple, Mrs. and Mr. Sharma are to be seated next to each other, and Mrs. and Mrs. Ahuja are not to be seated next to each other. Right? Our problem for circular arrangement, let's say n people are to be arranged around a circle, only relative positions are there. So that's why the answer is not n factorial, but n minus 1 factorial. Because a circle does not have a starting step and an end step. The whole idea of circular arrangement kicks only relatively. So we place one person sit there, around that person, or next to that person, next to that person, this side and that side, we seat everybody else. We want to follow the same approach. Mrs. and Mr. Sharma are to be seated next to each other. So I say, Mrs. and Mr. Sharma, 2 seats are taken by them. It's the Sharma family. Then we have 1, 2, 3, 4, 5, 6 seats left. Right? Around these 2, these 6 can be placed. The second condition were not there. Mrs. and Mr. Ahuja are not to be seated next to each other. Assume that condition is not there. Then we can say 6 people, 6 seats. Now the circular arrangement idea is not there because the Sharmas are together. They anchor my positioning. I'll have 1, 2, 3, 4, 5, 6. 1 position to the left, 2 positions to the left, 3 to the left, 4 to the left, 5 to the left, 6 to the left. Out of this block, I'm through 6 factorial. To keep one thing in mind, Mrs. and Mr. Sharma are together. They could be Mrs. and Mr., Mr. and Mrs. Both ways. So my answer would be 2 into 6 factorial. I could have Mrs. and wife and husband, husband and wife. Both will work. But it's not enough. It's not my answer. It's not 2 into 6 factorial because the 2 into 6 factorial does not account for the fact that Mrs. and Mr. Ahuja are not to be seated next to each other. How do I handle that not to be seated next to each other? I say, okay, let me count all possibilities where they are seated next to each other. I'll subtract that. My answer should have been 2 into 6 factorial. From this, I'm going to subtract all possibilities where they are not seated next to each other. Nice. So, all possibilities where they are indeed seated next to each other. Sorry. That means Mrs. and Mr. Ahuja could have been in these 2 seats, or these 2, or these 2, or these 2, or these 2. Combination 1, combination 2, combination 3, combination 4, combination 5. Assume they are in these 2, then there are 4 seats remaining, 4 people, 4 factorial ways. They were in these 2, 4 seats remaining, 4 factorial ways. Or the number of ways that I should not count is 4 factorial into 5. Why 4 factorial? After I have put Mrs. and Mr. Ahuja, 4 seats are remaining, 4 people, 4 factorial ways. Why 5? Mrs. and Mr. Ahuja could be seated next to each other in 5 different combinations. 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6. One other thing that I need to remember here, which I kind of overlooked when I did this question originally, is the fact that Mrs. and Mr. Ahuja in each of these combinations could be husband and wife or husband and wife. Husband and wife, husband and wife. Husband and wife, husband and wife. So it is not just 4 factorial into 5, it is 4 factorial into 5 into 2. So for the husband and wife being, Mrs. and Mrs. Sharma being there in one position, they could be in husband and wife here in taking these 2 slots, and then I'll have to subtract this much. So if I had them here, I have 6 factorial combinations. From that, I'll have to subtract this. And then I could have them the other way around. From that, I'll have to subtract this. So husband and wife could happen both ways. It could be H and W, W and H for Sharmas. H and W, W and H for Ahujas. This is for the Ahuja part, this is for the Sharma part. Nice. Now, how do I combine this? I have to subtract one from the other. I have to keep one thing very careful in mind. Given one sequence of Sharmas, that is 6 factorial, I'll have to subtract 4 factorial into 5 into 2. The whole thing into 2, for all of these arrangements were husband, wife and husband. So 6 factorial minus 4 factorial into 5 into 2, whole thing into 2, husband and wife and husband. Each of those combinations. 6 factorial is 720. 5 into 2 is 10. 4 factorial is 24. This is 240. This is 2 times 720 minus 240. Which is 2 times 480. Which is 960. Excellent question. I'm going to go over the thought process one more time. I'm going to first think in terms of, hey, what do we do if we have the first condition alone in mind? Mrs. and Mrs. Sharma together. Both of them together. And 6 slots, 6 people, 6 factorial. Both of them together could be husband and wife and husband. 2 into 6 factorial. Total possibilities. So for each of those possibilities, one sequence of husband and wife here, I could have, I'm subtracting the scenarios where the Ahujas are also sitting together. So I'm sitting the Ahujas together. Because here, 5 ways. Each of those 5 ways, there are 4 factorial ways for the remaining 4 people to sit. And each of those 5 ways, I could have H and W, W and H, H and W, W and H, each of them into 2. 4 into 5, 4 factorial into 5 into 2, 240 ways in which we can seat the Ahujas such that they are seated together for each of those 6 factorial ways. For the husband and wife like this, then husband and wife like this. So my final answer is 2 times 6 factorial minus this number. Assuming that husband and wife are here, wife and husband are here, I'll have to subtract this. Assuming wife and husband are like this, I have to subtract this. So twice of 6 factorial minus this, 720 minus 240, 480, whole thing into 2, 960. Beautiful question, super challenging question.